Hi guys, welcome back to this video. Here I will show you how to solve trigonometric equations, the basic ones, with the sine function. And in another video I will do the same for the cosine function and then the tangent and cotangent functions. So the method I will show you is the one that I learned in high school, and even now after 10 years without doing any practicing at all, I still remember how to do it because it's mostly visual. So I hope that it will help you as well. The one thing you will need is to remember what the values of the trigonometric functions are in the first quadrant. And I will put somewhere a link for a TikTok video I made where you can easily remember that. So for starters, we will start with a simple example. Sinus x equals 1/2. So the method is the same for all the functions. You just have to be careful which one you are reading. So in our case, we have the sine function. And we just have to remember on which axis do we read the sine value. So we do it on the y-axis. Meaning that if sinus x equals 1/2, it's going to be 1/2 on the y-axis. Okay? And now what you do is you just make a parallel line to the x-axis. And it will intersect this trigonometric circle in 2 points. And based on those 2 points, you'll get these two rays, which determine 2 angles. So here we have this angle alpha 1, and here we have our angle alpha 2. Always remember that we are reading counterclockwise because that is the natural way to read the angles. So we start from 0, which is basically the x-axis, and then we just go counterclockwise because we want positive angles. And now the question is, how do we determine alpha 1 and alpha 2? Well, alpha 1, since it's in the first quadrant, we will read it from this table for trigonometric functions. And if you look it up, you will see that sine of pi over 6 is exactly 1/2. Pi over 6 or 30 degrees, depending if you want to use radians or degrees. But don't ever mix, stick to one. Either write everything in radian or write everything in degrees. Okay, the first quadrant is always easy because it's from the table. Now the second one, as you can see, alpha 2 is this angle here. And if you note, and you should notice that if I would continue a bit more, I would make 180 degrees or pi. So this whole thing is pi, but my angle alpha 2 is pi minus this part here. But this part here is the same as this part here, meaning that alpha 2 is pi minus that part, and that part is pi over 6. So we have 5 pi over 6. And there we have it. When you find alpha 1 and alpha 2, it's really easy to determine all the solutions. Basically, the solutions will be x1 equals alpha 1 plus 2 pi times k, and x2 equals alpha 2 plus 2 pi times k, where k is some integer. Why do we have this plus 2 pi times k? Well, because the sine function has periodicity 2 pi, meaning okay, this is alpha 1, but if I make a full circle, I would get back to the same angle. If I make another full circle, I still get back to the same angle, and we have the same value for sine, and so on and so on. Also, I can do it in the negative way. That's if I would go clockwise, so I can do a full circle, again full circle, and so on. So I still would get the same value. That's why I have k to be an integer and 2 pi because it's the period. Meaning that our set of solutions, let's say, we can denote it with, let's say, this s as solution, so it will be pi over 6 plus 2k pi, where k goes through all integers, together with 5 pi over 6 plus 2k pi, where this k again goes through all integers. And there you have it. That's the solution for yeah, this is better. And there you have it. That's the solution for the equation above. So what you have to do, this value here, you have to denote it somewhere on the x-axis. So we have 1/2, here it is. Make a parallel line with the x-axis and it intersects in 2 points. This one is in the first quadrant, so we read it from the table, and we note that it's pi over 6 or 30 degrees. The second one, we notice that it's half a circle, so 180 degrees minus this part here, which is the same as this part here. So it's pi minus pi over 6, and we get the second angle. When we have these two basic angles, then all solutions are determined of this form. So alpha 1 plus 2 pi over times k, and alpha 2 is 2 pi times k. And then we can just write down what the solution set is. And that's it. Let's do one more example with negative sign, just to show this. So in this case, we have that sinus x equals minus square root of 2 over 2. So it should be somewhere here. So minus square root over 2. Again, we intersect the circle in 2 points. We have these two rays, and now starting from 0, so 0 starts always here. We have two angles, so here we have our first angle, and if I go up, here I have my second angle. So the biggest job always here is what are the basic angles, and then it's easy to write down all the solutions. So let us look at alpha 1. So if you notice, alpha 1 is pi plus this portion here. Okay? So the question is, what is that portion? Well, if I would extend this, I would get that this angle and this angle are the same, meaning that if I have minus square root over 2 here, then here I must have square root of 2 over 2, which is again in the first quadrant. And when you look up the table, you will see that the sinus of pi over 4 or 45 degrees equals square root of 2 over 2, meaning that alpha 1 is, as I said, pi, because you have this part here plus this small fraction here, which we figured out is pi over 4. So we have 5 pi over 4. Let us now look at the second angle. So alpha 2 is this part here, but if I would go a bit more, I would make a full circle, so I would make 2 pi. But then again, I have 2 pi minus this fraction here equals alpha 2. But as you can see, it's easy to know that this fraction here is the same as this fraction here or this fraction here, meaning that alpha 2 is 2 pi minus pi over 4, which is 7 pi over 4. And when you have alpha 1 and alpha 2, then you can easily write what your x1 and x2 are. So it's 5 pi over 4 plus 2k pi and 7 pi over 4 plus 2k pi, where k is some integer. And there you have it. And that's how you solve basic trigonometric equations using the sine functions. The sine function, I will do the same one in another video for the cosine, tangent and cotangent function, and then we will move on to some more complex examples. But remember, you will always come down to these equations: sine, cosine, tangents equals to something. That will always be at the end, so if you do not know how to solve them, you will never be able to finish the problem. So make sure to practice, and yeah, that would be all. Good luck, and till next time. Bye.